Okay, to graph this quadratic equation, let's first go back to our parent function and remember our 5 key values of our parent function y equals x squared and plot those on our graph as dashed lines. Next, we'll look at our equation that we have in vertex form and identify our vertex and our transformations of this graph. Now, there are 2 ways that you can graph this equation. The first method I'm going to show you is using the vertex in your transformations of left 5/2 and down 25/4. Start by plotting your vertex. Then we use our parent graph, key values from our parent graph. Remember, from our vertex we have +1 over 1, so back 1, up 1, back over 2, up 4, back 2, up 4, and that'll give us our graph of this equation, y equals x plus 5/2 quantity squared minus 25/4. The second method you can use is by using a table of values from your vertex form of the equation. So again, on this on this table of values, you're going to have your vertex, and you need 2 points above, 2 points less than your vertex, which I'll use -3 and -4, 2 points greater than your vertex, so -2 and 1. Now you can plug this in either into your vertex form of the equation or in the standard form, the original problem given to you. In this case, plugging into this original problem, x squared plus 5x, actually saves us some time and is easier to work with. We'll have less fractions to deal with. So I'm going to plug it into our original equation in this example. Simplifying down, we get the point -4, which we'll plot on a graph. Notice this plots exactly when I use the other method. It's still on the same graph, so either method works. Now plugging in -3, we get -6, plotting that on our graph. There's our vertex. Now let's look at 2 points greater than our vertex. Plugging in -2 into our original equation, we get -6. And plugging in -1 into our original equation, we end up with -4. And this is how you graph a quadratic equation when vertex form has fractions.